Welcome back, and in this lecture we are continuing our circular motion part. One lecture already have done on this, and so in last lecture we have learned like we have uniform circular motion or non-uniform circular motion, depends on whether the body is accelerating or not. Okay, uniform means there is only one acceleration, that's what centripetal acceleration. Non-uniform is apart from centripetal, tangential acceleration will be also there, right? Okay, these things we have done, and basics like how you write this motion in terms of angular thing, like angular displacement, angular velocity, acceleration, all these things we have done. So today we learning, we continuing this topic and learning the type of what circular motion. So again we can say two type based on how the objects are rotating. So one we can say like in horizontal plane, and then we have what, vertical plane. Okay. So today we will learning about what, horizontal plane, means the body is moving in a horizontal plane. So it's simple to understand, like suppose some body is there and you move like this circle. Okay, this is your horizontal plane, right? But you are moving like that way, right? That become what, vertical plane. So what will happen, that we will see. Okay, yeah. So today we are learning about horizontal plane first. Okay, we are starting with what, horizontal plane. So I should try like proper name, circular motion in horizontal plane. So we will talk, there are few problems which are very famous, repeated many times in our NEET exam. We will talk about them. So when a body is moving in a circular path in horizontal plane, right, like you have a circular road and car is turning on that circular road, then that is called what, in a horizontal plane, right? Yes. So we will talk about them. So suppose this is a very important problem that we will talk about first this problem only. So turning around circular rod. Okay, turning around circular rod, right? So this is a very daily life problem, and this is also very important from exam point of view, because many times they ask very simple question, okay, based on this. So what is the idea? When you are turning around a circular rod or very sharp rod, then you have seen that your vehicle will skid. So in order not to skid our vehicle, we do two things. One thing is what, if you have seen that the road which are circular and turning circular, their one side is higher than the other side, right? They are lifted from what, one side rod. So that's called what, banking of the rod. Okay, and sometimes you see that if a very sharp circular turn, then they make it rod what, very rough, means they increase simply the friction. So why we need this banking and friction? In order to your balance your what, centripetal force, in order to provide a centripetal force, because when you are turning around a circular rod, you get what, additional force, what, centripetal force, right? So in order to balance that, we need another force, that's called always what, friction force. So friction we need, sometimes we have seen that if a rod is not too much sharp, then only friction is enough to what, turn around that rod safely. But sometimes mainly the big rods like highways which are turning, they have what, banking. Okay, one side is lifted always higher than what, other side, right? So these two things are generally needed to what, provide or balance your what, centripetal force. So we learn one by one about them. Okay, so first we learn, suppose you have a rod and you balancing this centripetal force by just friction alone. You making the rod little rough, so that friction is increased. So first we are writing like friction alone. Friction alone. Suppose you make a rod rough and now you are turning on that circular rod. Let me draw it. Suppose this is your rod. Okay, your vehicle is here and you are turning on this rod, right? Yes, you are moving in that direction and you are turning around this. Okay, let's write what forces are acting. Your weight will act straight what, downward. Actually should be into the board. I cannot draw that, right? You can understand. Yes, you are on a ground, so your mg is what, straight towards the ground, right? Yes, so mg here, and look here, the normal reaction will be in this direction, upward, means what, upward. Okay, like if my vehicle is on board, then this mg will be into the board and normal direction will be what, outward the board, right? Yeah, and centripetal force mv square r, thus your friction force which what helped, okay, to what, balance it. So let's write for we want always we trying to know that what is the condition so that our vehicle does not skid, okay, on this road, we move what, safely. Okay, so these four forces should be balanced. Friction force should be equal to what, mv square by r how you said like this one, it should be more than or at least equal to what? Your centripetal force, so that your vehicle does not skid. Let me write in words also. For vehicle does not skid. If you don't want to skid it, then what condition you need? That frictional force should be more than what? mv square r, or at least what? Equal also, right? That should be more. Okay, so in this equation you have seen, like we also know that n normal reaction is equal to what? Mg. Then we know that frictional force also equal to mu into n means what? Mg. So if I put that here in this equation, then what I will get? I will get mu mg should be greater than equal to what? Mv square by r. Okay, m we get cancelled. So what they ask main question to us, the safe velocity. What is the maximum velocity we can turn around a circular rod? So and this question was asked many time in our exam. So let's solve this. So you see v square, okay, r goes that time, mu rg should be greater than equal to what? At least v square, or we getting final that our safe velocity should be less than or equal to what? Opposite I am writing now, is mu rg. Small formula but very important formula. This is the maximum speed you can turn around a circular rod, so that it does not skid or does not what? Slide on the rod, okay, safely. So this is what? The minimum, or you say maximum velocity with which we can turn around what? Turn around a circular rod, okay, safely, right? Yes. Till that velocity, your velocity is equal, you say simply like this one, mu rg. Okay, this is the maximum velocity, right, which you can turn around a circular rod so that it does not slide. If your velocity is more than that value, mu rg, then you will what? Skid. Okay, here r means radius of this circle. You are turning around circular rod, that's radius r. Okay, so mu is coefficient of friction, you know, no need to write. Okay, r is what? Radius of this circular turn, and right, and g is what? Acceleration due to gravity. So this is what required, the speed which you can move or you can travel on a circular rod without what? Skid. Okay, now second method is what? By banking. Okay, so we are writing just by banking alone. Okay, you can bank your rod, one side will be higher than other side. Again you can turn safely. Suppose this is your rod, it will look like that way, one side will be little higher, right? This angle called theta. So this is your circular rod like this one. Okay, this is the rod and your vehicle is what? Here. So this is the width of the rod, let's call it b. That's the height of banking, how much you are banking. Okay, how much you rising from other side. Okay, so I am writing here b is the what? Width of the rod, and h is the height raised. Okay, correct. Okay, this is angle made theta. Now look here, suppose when your vehicle is here, then how forces are acting? Mg will act straight downward. Okay, mg force. Then normal reaction is always perpendicular to surface, this will be normal reaction, right? No friction here. Okay, friction all alone we did here, now alone banking only. Okay, then centripetal force will be toward the center, that's mv square by what? R, correct? Okay, now what you have to do, let's write the component of n along the center and perpendicular to center. Let me use different color. So this angle is what? Theta. So that angle will be also theta. Why? We have learned in definition, right? Okay, so that component becomes simply n cos theta, and component I should write like the direction, little I wrote wrong, I should write mv square in this direction, mv square by r, and component of that becomes what? Simply n sin theta, right? These are the forces. Suppose you balance these forces, then what will happen? Let's balance them. We write like this one, n cos theta is equal to what? Mg, equation 1. Then n sin theta is equal to what? Mv square by r, equation what? 2. Let's divide these two equations, means 2 by 1. When you divide this, n get cancelled, you get tan theta is equal to what? Mass get cancelled. Okay, v square by rg. Again we want to find the safe speed only. So what is the answer? V square, or v is equal to what? R g tan theta. This is the maximum speed you can travel on a rod. correct. So this formula and this formula both has been asked many times in our NEET exam. Okay, very simple. Sometimes the friction alone given, then mu will be given to you. They ask you what is the maximum speed we can travel on this circular rod, mu rg, or the angle of banking is given. The angle of banking of a rod is given to you, tan theta is given. Then they said what is the maximum speed we can travel, or what is the safe speed we can travel. So mu rg tan theta. If you watch last topic, that this was there, that tan theta was simply equal to mu only, right? So same thing only, right? Instead of mu, what came here? Tan theta. When I talk only banking and only friction means what? Mu is coming, right? Okay, here additional one more question can ask in terms of this B and H. They can ask you how much height we should rise, correct? So if you watch carefully here, one tan theta we wrote already here, V square Rg. Then one tan theta we can write from geometry, right? So from geometry, if you see that tan theta is nothing but what? Perpendicular base means H by what? B. And tan theta already we learned here is what? V square by what? Rg. So this formula you can use to find either the width of the rod, is given, then can ask you the height of be rising, right now. The one side of the rod will be rising, so by what amount be rising, the h they can ask you. So either angle is given to you, then simply tan theta is equal to h by b, or velocity and these things are given radius, then b by h is equal to what? V square by rg anyway, right? Okay. Now next third point what we'll talk, we put them both together. Suppose a rod is there where friction also be making and what? Angle of banking also there, right? So same question they can ask for a cyclist also, okay? Exactly same question they can ask for what? Cyclist. Before going next, cyclist turning around a circular rod. So what happens? Cyclist, because car cannot bend, right now. So we are making the our rod itself what? Banking, right? But if your cyclist is there, he can bank, right? Now cyclist can bank. Again similar answer will come when you solve that cyclist problem. So by what angle we should bank so that he can travel at this speed, or he is banking by this angle, then what is the maximum speed he can travel on a circular rod? Same answer, this answer only. Velocity will be equal to what? Maximum is what? Rg into what? Tan theta. Or they will ask you angle of banking means tan theta, they will ask you, which is what? V square by what? Rg, correct? Cyclist can bank, but like a four-wheeler cannot bank, so we have to make the rod banking, correct? Yes. So same question can be asked for what? Cyclist turning around a circular rod. Okay. Now we'll talk the both points together. Banking also there and friction also there. Okay. Yes. Okay, we are talking about the third case, and generally nowadays we use these things. Okay, means the rod will have banking also and friction also. Okay. So we're talking both things, banking and friction both. Banking and friction both. Okay, so rod will have banking and friction both also. Again here we have two cases, like our direction of frictional force depends upon the speed of the vehicle actually. If vehicle speed is what? Small we say, then the friction force act what? Outward, and if speed is what? Very high, it acts what? Inward. So depends upon speed also. We can talk two cases, simple. So first is if speed of vehicle is small or smaller, or okay, it's moving at what? Slow speed. Okay, let's how it looks. This is our rod, and I'm saying that here friction also there and banking also there, right? Both things are there. We involve both things. Okay, this is the angle theta. This was a circular rod, and B is the width of the rod. H is the height we rising, right? And friction also there. So this is a vehicle here. Then let's write forces acting on this vehicle. Okay, straight downward is your weight mg, correct? Perpendicular to surface or rod is what? Your normal reaction n, okay, n, and friction force will act outward along this direction f, and central force will be toward the center, that's what? mv square by r. Now if you see carefully the angle, so if you draw a line straight here, that angle also what? Theta. You draw a line here, that angle also what? Theta, correct? Okay, let's write the component n along that direction is what? N cos theta, and along that direction is what? N sin theta. Okay, friction force component along this direction, this component is what? F cos theta, and component along that direction is what? F sin theta. Okay, let's write forces. So vertical direction forces, these forces, N cos theta plus F sin theta should be equal to what? Mg, equation 1. Forces toward the center, along the center. So here n sin theta here, mv square r here, and f cos theta. So n this minus that is equal to what? Mv square. N sin theta minus f cos theta should be equal to what? Mv square by r, equation 2. So we are interested in knowing that what is the maximum speed. Again we can turn on this rod when both banking and friction is there, right? Speed we want to calculate. Okay, let's calculate. So what do you do? Here we have n and here we have f. So remove this f. We know the f is also equal to what? Mu into n, right? Let's put it here. So this equation I am putting first here. So n sin theta minus mu into n cos theta is equal to mv square by r. Then putting in that equation, n cos theta, okay, minus f means what? Mu into n sin theta is equal to what? Mg. Okay, let's divide this equation. Take n common and cancel it. Okay, yes. Okay, so what I am saying, n you take common and cancel out. Okay, let's divide the equation. Dividing 1 by 2. Let's divide this equation and see what happens. So n I am taking common here, cancelling here, I am getting sin theta minus mu cos theta by cos theta minus mu sin theta is equal to m got cancel here, we getting v square by rg, correct? Okay, so this equation you can further simplify. Let's divide everything by what? Cos theta. Dividing this complete equation by what? Dividing by cos theta. Let's divide. So when you divide cos theta, what you got? You got v square by rg will be equal to sin by cos becomes what? Tan theta. Cos by cos becomes just mu. Cos by cos becomes what? 1 and mu into what? Tan theta, right? Or finally the velocity which we want to calculate, say velocity, should be equal to what? Root of rg comes here, rg into this term what? Tan theta minus mu upon 1 minus mu tan theta. This is the answer, or this is the maximum speed we can travel safely without skidding on a circular rod when friction is there and what? Angle of banking also given to you, right? So that's the safe speed, rg. Remember, when only like 10th angle of banking was there, the answer was like rg into tan theta, and only mu was there, then answer was root rg into mu, correct? And both are there, then this is a term coming, tan theta and mu both are coming, right? Okay, now by chance they ask this second case, if speed of vehicle is what? High, is very high, right? High speed, then what will change? This direction will get reversed, this direction will in that direction, friction force will be downward. So this equation will change. What will change? Simply these two symbols, they get what? Change. These symbols become simply what? Opposite, means both are minus, you just write plus, that's all. So what is the answer now in this case? rg tan theta plus mu divided by 1 plus mu tan theta. This will be the answer in that question if the speed of the vehicle is what? Very high. So this question was asked only once in our NEET exam, okay? Yeah. Maximum time they ask like alone friction or alone banking only, okay, which is very easier to answer. Okay, so these were example of like a motion in a horizontal plane, turning around a circular rod. You have three possibilities. You're turning around the rod when only friction is given, then safe speed becomes what? Root mu rg. Or only banking of the rod is given, then safe speed becomes what? Root rg into what? Tan theta. Or final case both are given, then this is the formula when the speed of the vehicle is small, and opposite of this means these two symbol becomes positive if the speed of the vehicle is what? Very very high. Done? Okay. So apart from, let's see some other examples, okay, where we talk about motion in what? Horizontal plane, okay. One problem is what? Your death well, if you remember, you have seen in circus, death well, people also call what? Rotor, right? Death well. What is death well? Yes, there is a vertical well, and those stunt guys, they what? Ride motorcycle and what? Cars on this circular well, correct? Na? And that doesn't fall down, right? So what they do is this is what? Well, correct, like this type, and they are rotating on this, right, in a circular path. right? They are here and they does not fall down. Why it doesn't fall down? Because of some forces. What forces? Let's write them. Okay, yes. So look here, mg is straight downward, the weight of that vehicle, right? And friction force is what? Upward, trying to stop it slide down, correct? Okay, so this is what centripetal force mv square by r, and that's what your normal reaction what n. So these four forces are balanced so that it does not fall down, right? So let's write n is equal to what? mv square by r, equation 1. Then you say that friction force is equal to what? mg, and we know that friction also equal to what? Mu into what? N, correct? Mu is equal to what? N. So let's put it here. F is also equal to mu into N is equal to mg, and N is what? Simply here mv square by r. So mu mv square by r by is equal to what? mg. M get cancel. So give attention here. If you want to rotate, okay, on this in this what death well, then you need to travel at some speed, minimum speed, okay, so that it doesn't slide down or fall down. So what speed? That is given by here. So look here, this become v should be at least equal to what? What it becomes? R g by what? Mu. This is the velocity you need to travel. Minimum velocity should move at this speed, okay. You should keep rotating at this speed so that you does not slide down, okay, you remains on that vertical wall, right? So this is what? Death well case, okay. They will ask you these things, what speed we need to travel, or if speed is given, they will ask you what we need coefficient of friction simply, right? So hope I did everything okay only. So let me check it once more. N is okay, mv square r, f is equal to mg, and f is also mu into n, n is mv square by r, correct, m get cancelled, so v square is what? Rg by mu, correct only, okay, yes. Apart from this, some other example like conical pendulum is also very popular problem. Conical pendulum. Also I forget to tell you here, this question can be asked in terms of what? Generally they don't ask in terms of linear speed, like I wrote linear speed here. They ask in terms of what? Angular speed. You can write, because you know the relation between linear and angular, you know v is nothing but what? Omega into r, right? R is the radius of this circle, right? So this answer you can also write in terms of angular by chance they ask. So omega will be what? Simply v by r you can write, okay, that will no big deal, right? Okay, so even you write then how this look, if you watch carefully, suppose you put it here, so v by r, you divide this answer by r, then how it looks, you know that omega will come what? V by r goes inside because g by mu into what? R, okay. This thing, this is a velocity divided by what? Radius. So when you divide radius, it goes inside, become radius square, r get cancelled, so you get this answer. This is in terms of what? Angular velocity, okay. Okay, conical pendulum we are talking. What is conical pendulum? You have a thread and tie some mass here, small mass m, correct, then you spin like that way, okay, in a what? Horizontal plane. So it get a shape of like a cone, if you see, right, like that. Yeah, you get like that type of shape, right? This is the radius r, this is the length of the pendulum, this is the angle made what? Theta, correct, yes. So this is called a conical pendulum. You get a cone shape. You take a thread, a string of a negligible mass, you tied a small mass there, then you rotate that mass like this in a horizontal plane, right? Yes. So here they ask two questions. One question they ask that at what speed we need to move this particle, okay, at what velocity moving, and they ask what is time period of, okay, rotation. So let's talk about the forces acting on this particle. This is a string, so along the string we will be having what? Tension force T, correct, okay. Weight will be what? Straight downward, mg. Then you take the component of tension along that direction, this angle also what? Theta only, that will become T cos theta, and that component will become what? T sin theta, and this will be your centripetal force mv square by r. So let's write component. So T sin theta should be equal to what? mv square by r, and T cos theta should be equal to what? mg. Let's divide them. When you divide them, what will getting? You say that tan theta is equal to what? Simply v square by rg. Already we have done. So at what velocity we need to rotate this? So v will be equal to simply rg into tan theta. Yes. Or they ask angular, then angular will be equal to what? V by r, right? So divide this term by r, then you are getting this answer. Like what answer you are getting? You are getting g tan theta, right, by what r, this we will get. You divide by r goes inside, become r square, when r get cancelled, so you are getting this is the angular velocity. Or they ask time period of rotation, then time period is what, 2 pi by what, omega, we know formula, right? So 2 pi is okay, and omega means what, this term. So when you divide this term, what you will get, your r will go up, g and tan theta will come what, down. This is one way to answer. And sometimes this answer, this is a radius, sometimes radius is not known, the length of this string will be known, then you know this is L. So L you write in terms of that r. So r in this is what, simply r is what, L sin theta, right? L sin theta. If you replace it here instead of r, what you will get, time period will be 2 pi root, r you are writing L sin theta, g tan theta writing sin theta by what, cos theta, sin get cancelled, so you are getting 2 pi root L cos theta by g. This formula was asked in our exam. The time period of a conical pendulum of length L making an angle of theta, right? Then what become 2 pi root L cos theta by what, g, correct? Okay, apart from this, what question they can ask you is this, like suppose you have some stone tied of mass m tied with a string and you are rotating in a what, horizontal plane, correct? Yes, here's tension T, here is what, central force mv square by r. So they can ask you what is the tension in that string. Tension, if you are moving at constant speed in horizontal plane, generally moves at constant speed, tension will be simply equal to what, simply mv square by r only, that's all, right? No problem. In conical pendulum it becomes component, you see, right? But if you are moving perfect horizontally something, right, you know, like you put some string here on board and you are moving on the board, this board, correct? That becomes what, board is like, I am talking horizontal, not vertical, then tension will be equal to what, same at every point, mv square by r. Now next topic, when we will learning like vertical motion vertical plane, this tension will be varying from when your pendulum is at this point, tension is different, when this point at every point the tension will be what, different, we will see in the next topic. Before that we do some numerical problem based on what, this circular motion what, horizontal plane. All these problems we have done, let's do some questions on these, okay? Yeah. So let's solve these few problems based on what, circular motion what, horizontal plane, okay? Yes. First problem, find the maximum speed at which a car can turn on a rod of radius 30 meter on a level rod, okay? So level rod means it's not rising, it's not raised, right? No banking. Okay, if mu is 0.4 between the tires and the rod, so it's a simple problem, only mu is given, so we know that safe speed in this case is what, simply mu rg. Yes, so these type of questions they have asked 2 to 3 times on NEET, direct like this one, and same in terms of angle also they have asked, okay. So mu is given 0.4, r is given 30 meter, and g is, we know, is what, 10, correct? Okay, so 10 goes here, this become what, simply root 120 meter per second, okay, that's your answer simply. Okay, look at the problem number 2. A car is moving at speed of 60 km per hour on a circular rod of radius 0.1 kilometer. What is the angle of banking? So here friction they did not say, only talking about angle of banking. So you know formula, this safe velocity in terms of angle of banking is what, rg into what, tan theta. We have to find tan theta, which becomes what, v square by what, rg, correct? What is v given? V is given 60 km an hour, converting into meter per second, so we have to write like this way, right? Already I told you, you want to convert kilometer per hour into meter per second, multiply by what, 5 by 18, right? Okay, so how much this comes? Okay, so cancel by 6 goes 10 times, 6 goes what, 3 times, right? So this is coming what, 50 by 3. Let me check it if I am doing wrong. So cancelling by 6, 6 goes what, 3 times, okay, 6 goes what, 10 times, okay, so 50 by this is a meter per second, okay. And what else given? Radius is also given to us, which are given 0.1 kilometer, so it becomes what, 100 meter. So let's write tan theta will be what? Tan theta will be simply v square 50 into 50 by 9 divided by r 100 into g was 10. So 1010 get cancelled here. 5 goes what, 2 times, so it's coming 5 by 18. Oh, theta comes what, simply tan inverse of what, 5 by 18. That's your answer, okay? Yes. Okay, let's see the next problem. So it says a string of length 0.1 meter cannot bear tension more than what, 100 Newton. So string is given, length given, and maximum tension it can have is given what? 100 Newton. If it is tied with a mass of 100 grams and rotated in horizontal plane, give attention because next topic will be vertical plane. So this same question can be asked for a horizontal plane or vertical plane. Calculate the maximum angular velocity. So horizontal plane we are talking, then I told you always what happens, there are two forces only acting. So T, tension will be always equal to what? mv square r, always, okay. So T is equal to what? mv square r, this in terms, because they are asking angular velocity if you see. So this formula also can write, we know m omega square into r, right? Just be putting v value, v is what? Omega into r, right? Yes, so we get this answer. Okay, look, we have to calculate simply what? Angular velocity. Angular velocity becomes what? Simply root of t by m into what? R. Tension is given to you. How much given? 100 Newton maximum tension you can have. Mass is given what? 100 gram, 100 into 10 power minus 3 kg, and radius of the is also given 0.1. Okay, 0.1. Okay, 2 zeros goes here, still 2 zeros remaining, goes for answer becomes what? 100 radian per second, right? Minus 1, minus 2 goes up, becomes again 100 here, so you can take outside. Okay, let's talk about fourth problem. Two stones of mass m and what? 2m are built in a again horizontal plane of radius r and what? R by 2 respectively. If the tangential velocity of lighter is n times of the heavier, tangential velocity is given of lighter is what? N times of the heavier, and they experience same centripetal force, what is the value of n? Same situation, you are moving in horizontal plane, then tension will be equal to what? mv square by r, correct? Yeah. So here they said, okay, we should not simply centripetal force is what? mv square by r. They said this is same, centripetal force is same, and radius and mass are given different. So how velocity will varies? You know, tangential velocity will be equal to what? Simply equal to what? Root r by what? M. Can you see? So because centripetal force is given same, then velocity was r by m and what? Root. So look here, they said velocity of lighter is what? N times of the heavier. This guy 2m guy calling velocity v, then that will be what? N times of v, correct? Let's put it here. Okay. So I'm writing here velocity of what? Lighter mass m, that I'm calling nv, by heavier mass I'm calling m. So radius directly proportional to radius. Radius of m is what? R, and radius the other guy will be r by 2. Inversely proportional to what? Mass. Mass of the small is what? M will come here, and 2m will what? Come here, right? So okay, so mass get cancelled, radius this will go up, become root what? 4 becomes, that becomes what? 2. Okay, v get cancelled, so and n you getting simply what? 2. So n is what? 2, correct? These were few problems based on this. Apart from this, let me talk few more interesting problem, some tricks which they can ask in our exam. Look here, this type of problem has been asked. Let's talk some like 5 type of questions I have done with you, then let's talk 6. They say like you have a cylindrical some vessel like this one of height L or R and radius we call what? R, correct? And this is fully filled with what? Some liquid, and liquid mass let's call what? M. Then say that suppose you rotate this about this line, okay, this line or this line at the end, okay, about tangent. This is spinning around this, okay, like that way. Then they say that if you spin about this edge, then what is the force exerted at this point? They ask what? Force, correct? So it's very simple and very important also. So what answer of this comes? The force exerted on other side, okay. You rotate about this point, then force on this point will be what? Actually m omega square L by what? 2. This you have to remember, these are shortcut. And no. Okay, then one more question is like that way. They say like some plate is rotating. I'm talking like rotating plate, some name I write, rotating plate. Some plate is rotating of radius something, okay, and its angular velocity is what? Omega. It's rotating at what? Angular velocity omega. Some insect is there on this, okay, this is center. So insect is what? Here, okay, and insect problem. Okay, you put an insect here or you some object here. If this object also moving with that plate, means it's not sliding, then what condition is satisfied? The friction force, okay, the centripetal force is throwing is outward, then friction force is trying to stop it, right? So friction force at least should be equal to what? Centripetal force mv square r, and friction force is what? Mu into what? N, mu into n. So if they are asking friction force, then this is the only answer, should be at least equal to the centripetal force, right? Or mu into n, n means what? Mg is equal to what? Mv square by r, this m goes here, so v is, if you see the same answer come mu rg. So they said r is not the radius of this disc, r is the distance of this object from the center, keep in mind, okay. R is the distance of this object from the center. Some object is sitting on this, or an insect is sitting on this rotating disc at some distance r from the center, and this is not sliding, okay, it's not coming to ground, or it keeps sitting there only. For that, what condition should be satisfied? The friction force should be at least equal to the centripetal force, or the velocity of rotation should be equal to what? That. This you can write again in terms of angular velocity also. If they are saying angular, then you write just v by r, right? So it become what? Mu g by what? R, right? Yes. And okay, one this type of question also they can ask you, like bowl problem, like we have done in our Newton's laws, that how much insect can climb here. Suppose this bowl is spinning at velocity what? Omega. A bowl is there, and what? Bowl is there, is spinning with some velocity what? Omega. Then if you put some object here, it will remain stationary here, right? So let's say from center to the center, that angle is what? Alpha. Okay. Then they ask the question that at what angular velocity this ball should rotate, so that some object placed at this point of mass m does not fall down, does not slide. In that case, when we solve this, answer come like this way, is g r cos alpha, that's the answer simply, okay, if you want to remember. So these are few extra problems, okay. And so we have done now what? The circular motion of horizontal plane. So in next lecture we will be covering what? The circular motion of vertical plane, okay. Yes, thank you.